Okay, hello and welcome to my channel. Today we're gonna talk about the hydrogen atom, one of the classic two-body problem in quantum mechanics. So first we're gonna introduce some variables. So first one is the x and p of the electron. Next is the x and p of the proton. Okay, and these are in central potential. So if you remember the one thing that I want you to remember in the potential, we're going to show that later after we've introduced these guys first. Okay, so with these we have the xe, let's say xei, commuting with the pej is gonna be equal to ih bar delta ij's. Okay, next is the same for p, j equal to ih bar delta ij. Right, so this is the properties of these x and p of electron and proton. Okay, next we're gonna move on to our Hamiltonian. So Hamiltonian now would have, well, two kinetic term, the electron term, the mass of electron, plus the proton term. Remember here the masses of the proton, and in the V, it is, well, this is, well, you have to take the absolute position, the absolute distance between these two, instead of taking V of XE and XP. So this is that thing that I want you to remember. I think back in part 1 or 2 of angular momentum. So xe minus xp. Okay, so that would be your potential. Right, so now we can introduce our quantum variables. Okay, so these are basically the thing where, so writing it out would be easier to explain. So we take the momentum, the center of mass momentum, which is the sum of the two momentum in our two particle. Okay, next is the center of mass position, which is of course not the sum, that is the relative exp. Now we'll divide this by the sum of the mass. Okay, so that is your center of mass position. Okay, next is our relative momentum, which we have to have these smaller, these guy to ensure that it would, well, not behave abnormally. Yep. Next is the relative position, which is just the xe subtract with xp. That is the relative position of these two particles. Okay, so once you have this, there are two things that, well, you can derive and kind of solve for your alpha and beta, because, well, you kind of want to know what it is in this system. So the first property we're going to use is the commutation between these two. So that would be the first one that we use. The commutation between x, small x, and small p give you ih bar. This would have I and j delta j. Okay, so now we're going to expand this into the xe and xp. So that would be the commutation between e minus xp alpha pe minus beta p is equal to ih bar delta ij. Okay, and now you see this term. With this over here ensure us that only this term and this term would contribute something. So we're gonna ignore the other term and we're gonna write what we have left here. Okay, so that would be alpha xepe minus beta x p equals to ih bar delta ij. Okay, and these two are delta ij. Therefore, with p plus, that would be a plus. Just 2 minus. Okay, so what that give us? Okay, pen died again. Okay, so what that give us is alpha times ih bar dij. These have I and j, I forgot. J delta ij plus beta ih bar delta ij is equal to ih bar delta ij, which you can group this out and that would equal to 1. So I'll just write that right away. Okay, so this is the first thing that you want. Second one is the commutation between the relative and the center of mass. This time we take a look at the commutation between our p, so we can get the alpha and beta, and the term x in the center of mass, this big X. Right, and this term is equal to 0 since these two commute. Okay, so expand these. These have I and J, so I might forget that, but yeah. MEXEI plus MPXPJ. MP and MEMP, you can factor it out immediately. That will give you 1 over ME plus MP mutation. J M and the alpha beta you can also take out, but we'll finish this term. XPJ. Alright, so with this you can take this out, and now what you're left with is, of course, as I said before, up here only these term would give you something. Right, so what that give you is, well, the minus ih bar delta ij over me plus mp times alpha me minus beta mp must equal to 0. And you want this to equal to 0. This is of course not 0, so this term must be 0. Okay, so that would be the second term that we want. Over here, me minus beta mp must equal to 0, and that's the second one that we want. So erase this part, and from 1 to 2, you're gonna get what your alpha and beta is. So from 1 and 2, we get that our alpha and beta is this one is MP over ME plus MP. This one is ME over ME plus MP. Right, and we're gonna stop now. We're gonna stop here today, and in the next video, we're gonna take a look at the expanded Schrödinger equation and trying to get our energy from wave functions. All right, goodbye.